Hello, my wonderful student. You are welcome back to class today. Um, the network was so bad yesterday, we could not enjoy the class. So, hopeful that we are going to have uninterrupted network today. All right. So, you are welcome back to class. Just like what I said yesterday, we are going to be looking at a new topic called trigonometry. It's a wonderful topic and is practical oriented and exam focused. And just like I said yesterday, that many students, they run away from that topic. Probably maybe they feel that the topic is hard or something, right? So, but at the end of this class, you will see that is a lovely topic and is a topic you can easily handle. Okay, so now before we dive into today's class, I want you to inform your friends that the class has started. So let's quickly do that in a few seconds before we commence the class. Okay, all right. So once you are around for the class, you are available for the class. Let us see you giving a thumb to the class. Okay, now I can see results and Uber is around. Okay, so we are still waiting for more students before we commence the class. Okay, you're welcome. All right, is there any other person that is joining the class? Let's wait for others and let's see before we commence. Okay, so ensure that you send the link to your friends, your classmates. Let them know the class have started. Okay, all right. I think we are having another person joining here. Once you are joining, make sure you are tapping the like button, okay, indicating that you are ready for the class. Okay, I can only see Scott and Hoover here. Okay, is there anyone? If you are just joining the class, just give a hi. Let's know you are here in the class. Okay, I can say familiar. Yes. And okay, that's familiar. All right. So others, once you are in the class, just give a hi. Let me know. Let's see if we have a good number before we commence the class. Yes, I think I'm seeing more people. Just give a hi. Give a hi. Let me know that you are ready for the class. If you are just joining the class, yes, I'm waiting for others. So I think I'm beginning to have good numbers, but I need you to give a hi. All right. Okay. So familiar again. This is Joseph. Okay. All right. You're welcome. Yes. What of others? Let me see you saying hi. You are just joining the class. Okay. Okay. All right. Because of our time, we just need to move straight to this class. And before we start, you are just joining the class, make sure you give a thumb to the class. That is your duty, all right, just to help this channel. Anytime you get to the class, you give a thumb. That means what we are doing is impactful. So giving a thumb means you are giving a like to the video, and that is your own duty, all right? Okay, all right, thank you for doing that. Okay, now, so we are moving down to trigonometry. Just like I said yesterday, for those of you that heard me, I said trigonometry is a branch of mathematics that deals with sides, the relationship between sides and angle of a triangle. Okay, all right, branch of mathematics that deal with relationship between sides and the angles of a triangle. When we say tri, we're talking about three angles or three sides. Okay, all right. So before we go properly into the triangles, now we have to begin to look at angles because we have angle in triangle. So we must know what an angle is. All right. So when we say angle, it's just angle is just the measurement of the measurement between two lines, okay, emanating from a particular point. The measurement between two lines emanating from a particular point, okay. All right, so if you have a line like this and you have another line, okay, the measurement of this is what we call the angle. All right, so or we divide it like this. If we have a line OA and we have another line OB, okay. Now angle here is described as the measurement swept by line OB from OA. All right, so that is how to describe an angle. All right, so and then we need to look at different types of angle because we have a lot of them. Okay, all right, so I'm going to start with the common ones that we are quite familiar with, which is an acute angle. Acute angle is a type of angle that lies between 0 degree and 90 degrees. Okay, the first one we are looking at is acute angle. Acute angle, it lies between 0 degrees and 90 degrees. So I move down to another type of angle, which we call obtuse angle. Obtuse angle. Obtuse angle is the angle that lies between 90 degrees and 180 degrees. So I can just give you an example of obtuse angle. So if you say 100 degrees, so it's an example of obtuse angle because 100 lies between what? 90 degree and 180 degrees. So we also have reflex angle. Reflex angle. That is between 180 degree and 360 degrees. So any angle that lies within this range, we call such angle a reflex angle. Example of such angle is 200 degrees. 200 degrees lies here. So it's an example of obtuse a reflex angle. Okay. So we now have other type of angles which we call right angle. Right angle. Right angle is the same thing as 90 degrees. Okay. And then we also have angle on a straight line. Angle on a straight line, that is 180 degree. This is another example of angle. We also have another type of angle which we call angle at what? At a point. At a point. Angle at a point is 360 degrees. All right. Okay, so I will just give us two more examples. Okay, we have complementary angles. Okay, complementary angles. Now, two angles are complementary if the addition is 90 degrees. Okay, all right. Two angles are complementary if you add them together and you have 90 degrees. Example of complementary angles are 40 degrees and 50 degrees. Okay, you can always give me an example of complementary angles. Now, I want you to drop it in the comment section if you understand what I just said now. Give me example of complementary angles with what I define now. Okay, example of complementary angles. Don't forget what I said about complementary angles. I said two angles are complementary. Their addition is what? 90 degrees. Okay, so give me an example of complementary angles. Okay, that will show that you are with me. Is anybody giving me one here? Anyone? Yes. Example of complementary angle. Okay. All right. Maybe probably some of us are typing. I want us to move with time so that we'll be able to cover a lot. Okay. So just think of any two angles. When you add together, it will give you 90 degrees. So we have another one, supplementary angle. So two angles are supplementary if the addition is 180 degrees. Okay, when you add the two together, you have 180 degrees. Example of such is 100 degrees and 80 degrees. So such angles are called supplementary angle. Okay, so these are examples of common angles. Okay, now let us now move down to triangle. So what do we call triangle? Now all of these definitions are very, very important. So I expect you now to get all those definitions because it's going to help us to solve problems. And you see, mathematics has to do with backgrounds. Just like I used to tell students, the background is very, very important. It will help you because you are going to be building on the foundation. Once the foundation is okay, it will help you to strive well in doing well in that particular topic. Okay. All right. Now, so now let us now look at the triangle. Okay. Now, what do we call triangle? Because we are looking at trigonometry, and rightly we have said that trigonometry is a branch of mathematics that deals with relationship of side and angles of a triangle. Okay, now let us now look at a triangle. So what do we call triangle? A triangle is a geometrical shape with three sides and three angles. Okay, a geometrical shape or a geometrical closed shape with three angles and what? Three sides. That you can, it's called tri. Tri means three. Okay. All right. So now we are going to be looking at different types of triangle, which is very, very important. So we'll be looking at that. Now let us look at different types of angle. Okay. Now the first one we are going to be looking at now is let's look at equilateral triangle. Equilateral triangle. Okay. Now, what do we call equilateral triangle? Let me just draw a sample of a triangle here. I'll call this A, B, and C. Okay. So equilateral triangle is a type of triangle which all the sides and the angles are equal. Okay. I can simply tell you the angle of equilateral triangle, that is 60 degrees. Okay. So equilateral triangle is a type of triangle in which all the sides are equal and all the angles are also what? Equal. So the angle of equilateral triangle is 60 degrees. Sorry, is 60 degrees. So now let's move down to another type of triangle. We have the isosceles triangle. Okay, this is the type of triangle with two equal sides, and two equal angles. Two equal sides and two equal angles. Okay, so once we have a triangle with two equal sides and two equal angles, we call such triangle what? An isosceles triangle. Okay, if all the sides are equal, it's called what? Equilateral triangle. Equilateral triangle is also called an equiangular triangle, that is equal angle. All right. Okay, so now let us look at another type of triangle. So we have scaling triangle. Okay, so what is special about this type of triangle? Now, it is a type of triangle in which the sides are not equal and the angles as well are not equal. So once you are given a triangle in which the sides are not equal, they are not the same, okay, or the angles are not the same, such type of triangle is called a scaling triangle. Okay. All right, so let's look at another type of triangle. We call this right angle triangle. Okay, this is the fourth one we are going to be looking at for today. All right, so now right angle triangle is a type of triangle with a right angle. You know, when I say right angle, now you know the meaning of a right angle. I say right angle is what? 90 degrees. That is the type of a triangle that one of the angle is what? One of the angles is what? 90 degrees. Okay, so when you are giving a triangle and you observe now that one of the angles is 90 degrees, so you call that type of triangle what? A right angle triangle, because there is a right angle there, so there is a 90 degree there. Okay, all right, so we are going to do a lot on right angle triangle, and that is what we want to go to before we now look at other type of triangles. Okay, so we try and look at several problems on that. All right, so now just like I brightly said, you see this right angle triangle is going to help us to solve a lot of real life problems. All right, I don't know, maybe you ever wonder that how will a surveyor take a width of a river without even crossing the river, and it's going to get the dimension, the width of the river. You will see an engineer that is going to tell you the height of a story building without even climbing the building. Okay, so you see everything is explained in trigonometry. So the explanation is in trigonometry. We are going to be looking at those type of question that is going to give us the idea of what the engineers are doing, what the architects, what the surveyors are doing. So you can see it's going to be an interesting topic. Okay, so now let us move down to right angle triangle, because that is where I'm moving. So I'm starting with this, the right angle triangle. Okay, all right, so how does it look like? The right angle triangle looks like this. Okay, let's label the vertex A, B, and C. Vertex is just where two lines meet. Okay, this is C, vertex B, and the A. Right, so this is right angle. So, and this is a reference angle. Now, this right angle now is 90. So that makes this to be a right angle triangle. Okay. Now, in the right angle triangle, all the sides are named. They have a particular name. Now, this is called the opposites. This is called the adjacent, and this is called the hypotenuse. All right. Hypotenuse is the side that is directly opposite to right angle. So you need to get that. All right. Many students find it difficult now to identify this. I want you to get the explanation better, so that when triangles are twisted, they are turned upside down, you can still identify your opposite, adjacent, and hypotenuse. Now look at this now. The main thing you need to know is that, okay, my hypotenuse is always directly opposite to right angle. So if you are giving this type of triangle now, and I call this one right angle, okay, and I ask you, what is hypotenuse? All you just need to do is that, okay, what is that side that is facing the right angle? This. So very easy to identify. So this is your hypotenuse. Now the next thing is your adjacent. How do you know your adjacent? You see, for me to identify my adjacent, or to differentiate between adjacent and opposite, now I must have a reference angle. Now, what's the reference angle? This. If I don't have this, I may not be able to identify my adjacent and opposite. Okay, so the adjacent is that side that has the reference angle and the right angle. So that line that have the reference angle and the right angle. So that side is called an adjacent, while opposite will not have the reference angle. Okay, all right. So now look at this now. Look at this. Let me quickly give you a test. Let's see if we can get that. We have A, B, and C. All right. Can you tell me what is side A from the explanation I just gave you here now? So what is side A? Is side A opposite or adjacent or hypotenuse? So I want you to quickly do that. Drop that in the comment section. Identify side A. This is side A. So what is side A? Is it opposite, adjacent, or hypotenuse? Yes. I want you to drop your answer in the comment section. Okay. Okay, all right. Somebody said adjacent. All right, let's wait for others. Okay, somebody said, okay, this code said is opposite. Okay, let's wait for others. Arowolo said is adjacent. Yes. Side A. Okay. Ajoke Ade said it's opposite. Yes. Let's wait for others. Please quickly drop your answer so that we'll move faster. Okay. I'm waiting for others to drop their answer. Yes. Okay. Yes. Anyone dropping answer here? Yes. Okay. Is anybody okay? Joseph, we have opposite, and Uber, we have opposite. Okay, good. Thank you. Thank you very much. Now, please, I'm going to tell you this now. If you are just joining the class, I told you that whenever you join the class, always give a thumb to this video. That shows that the video, the class is impactful. So always remember to give a thumb to the class. All right. And if you are just joining this platform for the first time, make sure you click on the subscription button so that you'll be notified anytime we are on here. All right. Okay. If you have not done that, quickly do that now. All right. Now let's move down to the question. Now, I asked you that what is this side A? Don't forget my explanation. I said adjacent is the line, okay, the line or the side that touches the reference angle and right angle. You can see it here now. Look at adjacent now. You will see it, this line adjacent is touching the reference angle and the right angle. That makes it to be adjacent. Okay. Now look at the opposite here. There's no reference angle here and this. Now look at this. It's obvious now. Look at this line now. This line is touching reference angle and the right angle. Can we see that now? Okay. Now, can you see that? Now, it's touching, this is touching the reference angle and the right angle. So, you can see now, so this is adjacent. That means B is adjacent. So, if B is adjacent, there's no doubt about it that this is going to be opposite because it's obvious now. C is hypotenuse. I told you the side that is facing the right angle directly, okay, is called the hypotenuse. So, this is the hypotenuse. So, we just need to identify this. It's very easy. All right. Any line that is touching the reference angle and the right angle is adjacent. But the line that is just touching right angle, not touching the reference angle, is called the opposite. So I think by now everybody should be able to differentiate between the sides. It's very, very important. It will help us now to be able to solve problems, because what we are moving down to after all this now, we need to be able to identify it correctly so that we're able to solve conveniently. All right, good. Okay, thank you. So if you get the answer, I want you to give yourself a round of applause. That is very good, very smart of you. So if you miss it, don't be discouraged. The most important thing is that you have just gotten it now. All right, so now we can then now move down to the next thing. All right, so now I want us to look at the trigonometrical ratio. So that's what we are moving down to. Trigonometry ratio. Okay, I'm moving down to trigonometrical ratio. Now we are going to be looking at some functions which will help us now to be able to solve some problems on that triangles. Okay, now the first one I want us to look at now is the sine. All right, sine of angle is the ratio of the opposite to hypotenuse. Ratio of opposite to hypotenuse. So it's going to be your opposite over hypotenuse. Okay. Now the next one I'm looking at now is your cosine. Your cosine of the reference angle. is the ratio of the adjacent to hypotenuse. So it's going to be what? Adjacent over hypotenuse. Okay, and the last one, which is the tangent, that's tan theta. Okay, so that is the ratio of opposite to adjacent. Okay, that's opposite over adjacent. Okay, now this you need to master very well because we are going to be making use of these functions. All right, the first one is sine, the ratio of opposite to hypotenuse, cos, the ratio of adjacent to hypotenuse, and the tan, the ratio of opposite to adjacent. Okay, so these are the three major functions we are going to be looking at. But there's a way we can just con it in such a way that we can easily remember these ratios. So we have so ka 2. Okay, so we can just have this. Why this one represents your sine? Okay, this is sine, this is opposite, this is hypotenuse. So this one is just going to be opposite over adjacent. Now look at this cos now. Cos is adjacent over hypotenuse. You can see it here. So tangent is opposite over adjacent. So you have it opposite over adjacent. So now you can write this one somewhere in your notes and make sure you master it so that anytime you are asked to give a ratio of cos, you know it's going to be this car adjacent over hypotenuse. So you should be able to write this one. So master this so ka 2, so ka 2. And let everybody master this. So we are going to be applying this. Now, let us move down to right angle triangle, where we look at, let's look at this. A right angle triangle, where this one is the reference angle. This A, B, and C. Now, look at it. If this is a right angle triangle, now the angles here, they are complementary. This angle and this angle here are complementary. In any given right angle triangle, the non-right angle triangles are complementary. Please, I want you to take note of that. They are complementary. So that means the addition is 90 degrees. So now if I call this, let me call this one x. I don't know what this one is. So that means x plus theta must give you 90 degrees. So it implies that x equals to 90 degrees minus theta. So this place now is 90 degrees minus theta. Okay, so in such a way that when you add the angles in a triangle together, the total sum of the angle we have in the triangle is 180 degrees. Right, 180 degrees. Now let us look at some trigonometrical equations and let's work with some problems. All right, now let me give you some problems and let's quickly do that. Example 1. Now solve the following. Solve the following. Cos theta equals to sine 40 degrees. That's the first one. The second one, sine alpha equals to cos 2 alpha. All right, now let us see how do we solve this type of problem. Now, the first thing I need to know is the relationship between sine and the cos. sine and cos, the relationship. Now let's look at it. Now here, let's look at it. Sine theta is the same thing as cos 90 minus theta. And also cos theta equals to sine 90 minus theta. You can see the relationship between the two, right? Sine theta is cos 90 minus theta, while cos theta is sine 90 minus theta. It's very easy. Now look at it. If I say what is sine 30, everybody know the answer to this. Sine 30 is 0.5, or you say 1/2. Is the same thing as cos 90 minus 30. And that's the same thing as cos 60. Cos 60 is also the same thing as 1/2. Okay, so you can see the relationship. So now you need to master this relationship, because that is what we're going to be making use in solving this trigonometrical problem. Okay, so I want to believe that everybody has gotten this. So now in your notes, quickly put this one down. All right, so I want every one of you to have this in your jotter. Put it down. Cos theta equals to cos 90 minus theta, while cos theta equals to sine 90 minus theta. Okay, so let's take note of that. Now I think with this now we should be able to solve this one. Now look at the first one we have here. Cos theta equals to sine 40 degrees. I want to know what theta is. So how do we do this? Now what I'm going to do now is I will change this cos to sine, such that we are going to be having sine in both sides. Now I'm coming again. Listen. Now to solve this, I will change this cos theta to sine. Now what is the equivalence of cos theta? Now you just come here. Cos theta is the same thing as sine 90 minus theta. It's equivalence. Okay, so that means in place of cos theta now, I can put sine 90 minus theta. Okay, so can we plug in that now and see? So this is going to give me sine 90 minus theta equals to sine 40. Let's say 40 degrees. Okay, now can you see now what is changing? This is the same thing as this, so nothing has changed. Okay, can we move on now? Right. Now when you look at this, we are equating these two parameters. You say, okay, sine of 90 minus theta is the same thing as sine at 40 degrees. So now this content we have inside will be equal to each other. So we have 90 minus theta equals to 40. It's just like we are doing away with this sign. All right, so now you can make theta the subject of the formula. So we have minus theta equals to 40 minus 90. So minus theta equals to minus 50. So therefore, theta equals to what? Equals to 50 degrees. So that's going to be the answer. Okay, so theta equals to 50 degrees. So if you punch your calculator now, press cos 50. When you press cos 50, you write the answer somewhere. Also press sine 40. You will see that you have the same answer. All right. Okay, so that's how to check back if your answer is correct or not. So, and don't forget, once you are getting your answer, don't forget to put the units, because we are talking about angle. So angle is measured in degrees. All right, so that's the first part. Now let us look at the second question here. Now let's look at the second question. If you are just joining the class and you have not subscribed to this channel, ensure you do that. Okay, so try and subscribe, and also give a like to this video. All right, so now let's look at the second one. So we have sine alpha equals to cos 2 alpha. Okay, how do we solve this? Now, see the way I'm going to handle this now. I want to get alpha. All I just need to do is just to change this one so that it's going to look like this. It will be the same function. I will change sine to cos. I already know whenever I want to change sine to cos, whatever I have here, I will subtract it from 90. So I now have cos. I see sine theta equals to cos 90 minus theta. So here now, this is going to be cos 90 degrees minus alpha equals to cos 2 alpha. Okay, hope you get that now. So once you change sine to cos, just write 90 minus whatever you have here. It's as simple as what we have here. All right. I want to believe everybody is flowing. All right. Okay. Okay, good. Good. Okay, so I can see we are flowing. Now, yes. Now let's see now. Okay, so the next thing now is to equate this to this. You equate this one to this. So you have 90 degrees minus alpha equals to 2 alpha. Okay, all right. So what is the next thing? You can collect the like terms. Now let us transpose minus alpha. We bring it here. So the sign changes. So you have 90 degrees equals to 2 alpha plus alpha. All right. So I hope you have written this one down. So because you are going to be making use of it, I'm going to give you something to do now after this. So make sure you have this in your notes. Okay. So now here you have 90 degrees equals to 3 alpha. Okay, so now you can divide both sides by 3. So you have 90 degrees over 3 equals to 3 alpha over 3. Okay, so 3 goes in 90. That is going to give you 30 degrees equals to 3 cancel 3. We have alpha. So that means alpha equals to 30 degrees. All right. So I want to believe we all get that. Now let us see. Let us see if we can quickly try this. Let's try this. Let me see what we are going to have as our answer. Try this. Solve for theta. If, or let's say solve for x. If cos x equals to sine x minus 10 degrees. Okay. Now, can we do this one now in a few minutes and let's see what we're going to have. So you can drop your answer in the comment section. So solve for x if cos x equals to sine x minus 10. Now let's quickly do this one and drop the answer in the comment section. Okay. So I've observed that some of us have not even give a thumb to the class. Ensure you do that. If you have not given a thumb to the class, make sure you like the video. All right. So okay, let's solve the problem and drop the answer in the comment section. Let's see what we have. Okay, yes, somebody have dropped an answer. Familiar, I've dropped an answer. Let's wait for others. Okay, let's wait for others for the answer. Yes. Okay, I can see Riscott with an answer. Okay, somebody dropped 47. Okay, I can see 47. X is 47. X is 50 degrees. I think that's supposed to be 50 degrees. Yes, Uber have dropped an answer. Yes, let's wait for others. Make sure you are doing something. Okay. Right. Okay. Someone else have dropped an answer. You can see X is 50. Okay. Yes. Others. We are waiting for others. Okay. You have less than 30 seconds. You have less than 30 seconds. So after that, we are going to solve the problem together. Yes. Ajoke Ade, we have X equals to 50. Okay. Adenike, yeah, just greeting. I need your answer. Now drop your answer. Yes. So in the next few minutes, few seconds, we are going to solve the problem together. Okay. Yes. Any other person? Okay. All right. So I think now we can solve the problem together. Let's see what we're going to have as an answer. Let's see those people that got the correct answer. All right. So I see observe that some of us are not. We have some new people that are just joining that I'm seeing for the first time. Once you are joining for the first time, make sure you click on the subscription button and give a like to the class. Okay. Now let's look at this. Now we have cos x equals to sine x minus 10 degrees. Okay, so now how do we solve this? Now I said something. Change this to sine. Now whenever you want to change cos to sine, all you just need to do is just have 90 minus whatever you have here. That's it. It's so simple. You have that in your notes. So now this side will turn to sine 90 minus x. Okay, so since we have changed this to sine, so this is going to turn to 90 minus x, so equals to sine x minus 10 degrees. Okay, so you can now equate this value since this and this are the same thing. So that means the value we have here must be equal. So we have 90 degrees minus x equals to x minus 10 degrees. Okay, so now here we collect the like terms. Now let's collect the like terms. So let's transpose the x here. So we have minus x equals to minus 10 minus 90. So once we transpose this, so the sign changes from plus to minus. So we have negative x, that is negative 2x equals to negative 100. So we now have x equals to negative 100 over negative 2. So therefore, x equals to 50 degrees. So minus cancel minus. All right. So the answer is 50 degrees. So if you get the answer, put your hands together for yourself. Yes, put your hands together for yourself. So we have smart students here. All right. Let me see you doing that. Put your hands together for yourself. That's a very good one. All right. Okay. So let us move down to something else that looks like this. I'll just give you this as a recap. All right, solve for alpha if sine 2 alpha plus 45 equals to cos alpha minus 10. Okay, so now how do we solve this type of problem? How do we solve this type of problem? All right, when you look at this one now, which one are we changing? You can change any of the two. You can change any of the two, but you can see this one is binomial. We have two terms there. So see the way I'm going to change. I'm changing this one to cos. If you want to change this to cos, don't forget, whatever you have here, say you subtract it from 90. So that means this side we turn to, see the way I'm going to write it now, it's going to be cos 90 degrees minus this we have here, 2 alpha plus 45. Okay, equals to cos x minus 10. All right, so that is what you have. So now you can just open the bracket entirely, or let's first equate this. Let's just equate this to this. Since we have cos in both sides, so we have 90 degrees minus 2 alpha plus 45 equals to alpha minus 10. All right. So now this is going to give you 90 degrees minus 2 alpha minus 45 equals to alpha minus 10. So we can collect the like terms here. So when you collect the like terms, let's see, we transpose this, we have minus 2 alpha minus alpha equals to, now we already have minus 10 here, minus 10. Let's transpose this. This is minus 45. Now you transpose 90. Okay, this is going to be plus, so we have minus 90 here. I hope we understand that. So when you transpose this, it turns to minus 90. Transpose minus 45 turns to plus 45. Okay, so here we have minus 3 alpha equals to, now let's join this and this together. Now this we have minus 10, this is minus 45. Hope you understand that. Plus 45 minus 40, minus 90 is going to give you minus 45. So that's minus 3 alpha equals to minus 55. Okay, here you can divide both sides by minus 3. So you have alpha equals to minus 5, minus 55 over minus 3. Okay, so alpha now is going to be minus, cancel minus. Now 3 goes in 5, that is 1, remainder 2, so we have 25. How many 3 are you going to see in 25? That is 8. So remainder 1 over 3. So that is the same thing as alpha equals to 18.33 degrees. You see, this is going to be the answer to the problem. Right? So I want to believe you all understand this. All right. So I'm going to give you something similar to this before we move to another phase of trigonometry. So let me give you something that looks like this. Okay. I want to believe you are up to that task now. Okay. So now let's do this. Let's try this. Try this. So for y, if sine 2 alpha equals to cos 3 alpha plus 10. Okay, now can we quickly do this one and let me have your answer in the comment section. Now let's do this one. Okay, let's do it within 2 minutes. Okay, so I want to see the first person that will give me the correct answer. All right, I know I have smart students here. So let's quickly do this one and let's see what we have as the answer. So once you have your answer, you drop that in the comment section. Okay. Okay. Yes. Is anybody with answer now? Okay. I think this question now, this is supposed to be alpha, not y. You have to solve for alpha because this is in terms of alpha. So solve for alpha. Right. So let's see. What do you have as your answer? Yes. Okay, somebody has given an answer. That's very good. Oh, Uber has given an answer. Yes. Any other person? Yes, Uber has given an answer. Okay, right. So, okay, I can see Familiary has dropped um, his own answer. All right, as 16. Yes. Let's wait for others. All right, the time is running. Time is running. Yes, we are waiting for Riscott and others. Okay, Riscott have dropped an answer. Okay. Yes. Okay. Ajoke Ade, I'm waiting for your answer and others. Okay. Now let's drop our answer. Yes. I'm also waiting for Christopher. I think I can see Christopher here. Yeah. Christopher, I'm waiting for your answer. Okay. All right. I can see that. Arubolo, I'm also waiting for your answer. I've not seen Arubolo's answer. Also, Adenike. Yes, and um, okay, and others. Yes, there are some names that I cannot read here. Okay. Yes, I can see. Okay, Ajoke Ade, I have y equals to 16. Okay. Okay. Is there anybody that want to add before we solve this problem together? Any other person? Any other person? Okay. 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 Now let's try and solve the problem together and let's see which one is the correct answer. Right. So now to solve this, now you change this sign to cos. Don't forget, once you change it to cos, it's going to be 90 minus whatever you have here. So that's all you just need to do. So I have this as cos 90 minus 2 alpha equals to cos 3 alpha plus 10. Okay, can you see that now? So now you equate this and this together. So we have 90 minus 2 alpha equals to 3 alpha plus 10. Okay, all right. So what's the next thing to do? We collect the like terms. All right, so we have minus 2 alpha. Now you transpose this, it becomes minus 3 alpha. Minus 3 alpha equals to, we already have 10 here. We have 10, so we transpose this. That's going to give us minus 90, right? Okay, we have minus 90. Now, when you join these together, what do you have? You have minus 5, minus 5 alpha. Now, this and this gives you minus 80. Okay, so then we can divide both sides by what? By 5, minus 5 rather. So we have alpha equals to minus 80 over minus 5. So we have alpha equals to, so minus cancel minus. Now 5 goes in 80 is 1. Remainder what? Remainder 3, that's 30. Now 5 goes in 30, that's going to be 6. Okay, so that means the answer is 16 degrees. Always put attention to units. So we have 16 degrees. So I want you to also put your hand together for yourself. Yes, I think the first person to give the correct answer is Uba. So let's celebrate our Uba. Yes, Uba was the first person to give the correct answer. Other follow suit, and also celebrate yourself too. You also tried for giving the correct answer. So it's as simple as that. So now what we have just done now, we have learned how to solve trigonometrical equations. So you should know what you have learned today. So what you have learned today, you've learned how to solve trigonometrical equation. All right, so I'm just going to introduce us to the next thing we are going to be doing in the next class. So that we have an idea, we just look at one or two questions, and from there we end the class. So in the next class, we are going to go in depth into what we are supposed to do. Okay, so we want to look at the application of trigonometry to right angle triangle. Now let's look at that. Application of trigonometry to right angle triangle. Okay, so we want to see how we can apply trigonometrical principle to solve some problem under right angle triangle. Now let us look at this problem that we have here. Now solve, okay, example, let's say example 1. Find the value of x in the figure below. Okay, now can we look at the problem we have here? Now the question asks us to find, okay, we have to find x, okay, right. Now we have to find x, side x in the figure below. So this is what we expected to do. So how do we go about this? Now to solve this problem, we just have to look at it. There are two ways of solving it, which I'm going to be introducing to us. Okay. Now the first way is making use of the Pythagoras theorem, and the second way of solving it is making use of trigonometrical ratio. Okay, so now I'm going to be, since what we have done today, we have been introduced to trigonometrical ratio. I'm going to teach you how to make use of trigonometrical ratio to solve this. All right, now let us see how to do it. And you know, in this aspect, we will be making use of our four-figure table to do one or two things. Now let's look at this. Now solution. How do you find x? Now the first thing is to identify which one is this opposite or adjacent or hypotenuse. What you're actually looking for is the adjacent, because it is the side that touches the reference angle and the this. Okay, so now, but the best way now is to first use, I'm going to make use of Pythagoras theorem, because that's the best way of doing it. Now let's see how we can go about it. Okay, so but then before I start doing it, I have to quickly introduce us to this. We have A, B, C. Now what is Pythagoras theorem saying? Now when you have a right angle triangle, Pythagoras theorem says, and this is the reference angle, sorry, okay, Pythagoras theorem says that the square of the opposites plus the square of the adjacents equals to the square of the hypotenuse. The square of the opposite plus the square of the adjacents equals to the square of the hypotenuse. So now I'm going to do that here now. So look at it. So now this is going to be opposite, which is AC square plus adjacent, that's BC square, equals to hypotenuse, that is AB square. All right, this side square plus this side square equals to this. That is what Pythagoras theorem is saying. So I'm going to be implementing that here now. The opposite square plus the adjacent square equals to the hypotenuse square. All right, so now let's do that now to solve this. So we have the opposite square, that's BC square, plus the adjacent square, AC square, equals to the hypotenuse square, that is AB square. Now in this triangle, right? So BC is 4 square plus adjacent square, that is x square, equals to hypotenuse square, that is 8 square. All right, so since we are looking for x, so now you move this to this side, so you have x square equals to 8 square minus 4 square. All right, so we now have x square equals to 64 minus 16. All right, so what do we have? So now that is going to give us x is what? X squared is going to be 48. All right, so that's going to be 48. So you can take square root of both sides. Okay, so when you take square root of both sides, we have x equals to square root of 48. All right, so we check your four-figure table or you punch your calculator. So let's see, what do we have as the answer to square root of 48? Is there anybody giving us the answer there? So if you have a calculator, okay, now let's see what is going to be the answer. Yes, anyone giving us the answer to that? Anybody giving us answer to that? Square root of 48. the square root of 48. Yes, anyone? Okay, so if you check your four-figure table or you check your calculator, you're going to be having 6.93. So that's going to be 6.93 centimeter. So this is going to be the answer to this side. So this is what we're going to have for this. Okay. All right. So yes. In the next class, we are going to go into making use of the trigonometrical ratio and also the Pythagoras distance. So I'll only explain what we are going to be doing in the next class. So the next class is going to be exciting and it's going to be practical oriented, just like we have said now. So what we are still doing now is just the introduction to trigonometry. All right, and don't forget what I said. The background is very, very important because you are going to be building on the foundation. So ensure that you don't miss any of the class. It's very, very important. And make sure that you are always in class in time so that you don't miss any part of the class. And that is the more reason why you need to subscribe so that you'll be notified at the right time and you get yourself ready for the class. All right. So tomorrow is going to be a wonderful time, right? So that should be in Nigerian time. So we should be on here around 12 noon. 12 noon, we should be online. So by that time, so we are going to be having the class. So we are going to be looking at making use of our trigonometrical ratio and also making use of Pythagoras theorem. Okay, so that is what we are going to be solving in the next class. So if I must ask you, what have we learned today? We have learned the definition of trigonometry, also what a triangle is. We looked at different types of triangles. Okay, all right, so can anyone tell me in the comment section what are the type of triangles that we looked at? Okay, now begin to drop it at the comment section. I want to see us dropping our answer. What are the type of triangles that we looked at? Yes, let us begin to drop. That shows that we are attentive and we are in the class and we are very smart to get everything I've said. So we looked at 4 types of triangles. Okay, now I just want us to do the recap of what we have done because that is what we are going to be building on in the next class. So, and I want everybody to be on point. Okay, so what are the type of triangles that we have? Okay, is anybody dropping one? Once you drop one, we move ahead. Okay, somebody have dropped one. So we have right angle triangle. Yes, right angle triangle. Yes, yes. Is there any other one? We just looked at right angle triangle. Any other triangle that we looked at? Is there, apart from the one you have mentioned? Is anyone dropping another one? Yes. Another person. Okay, good. Somebody has given us virtually everything. We have the equilateral triangle, isosceles triangle, scaling triangle, and right angle triangle. That is very good. Familiarity has given us the 4 types of triangles that we looked at for today. I want everybody to take note of it. Put it in your notes. Make sure you know those 4 types of triangle and the properties of those triangles. Okay, and more importantly, we looked at trigonometrical equation, and that was what we actually did. We did a lot of tasks on it, how to solve trigonometrical equations. All right, so that is the main thing we did today. All right, so tomorrow is another day, so we're going to be having an awesome time tomorrow. So you guys, you're going to see tomorrow. So take good care of yourself. Bye bye. And before you go, please, I want to know where you're watching from. Yes, make sure you drop where you're watching from before you leave. Where are you watching from? Okay. Thank you very much. Bye bye.